Hi, I'm Cody Coakley, and we are part of the Alabama Rocketry Association. We are the dream team, and we are going to take part in the Argonian competition. Our rocket is just above 7 foot, and it is we are using an L motor, and we're going to use air brakes to determine our apogee, predetermine our apogee.
Hi, I'm Parker Johnson. As Cody was saying, we're going to use an air braking mechanism to control our apogee during flight. We're confident that a air braking system that runs a calculation continuously will allow us to predict our apogee, and then by predicting the apogee of deployment, we believe that it gives us a better idea of where our golf ball will land. And to talk about the calculation is Nick.
Hi, I'm Nick Benedetto. We're using C++ to code the algorithm for the deployment of the air brakes. We have a while loop going, and once we hit a certain projected height, the air brakes deploy, and then once our projected height gets to our desired height, they retract. Now this is coded in C++, but we're transferring it to an Arduino. The Arduino will act as the brain, and it will be hooked up to a servo that's actually deploying the air brakes, but we'll talk about that right after this.
Hello, I'm Meyer Merker. I'll be in charge of the payload on our rocket. And for our payload, we're going to use the Titleist Pro V1 golf ball. It is the superior golf ball right now. I mean, all the pros are using it. It actually has a new advanced core technology with this integrated aerated rubber core. It's insane. It's meant for the ball to go faster with less spin. So it'll reduce that Magnus effect, so we can have a more accurate launch or deployment. And we'll be deploying this through a black powder charge when our drogue parachute deploys.
Alright, I'm Austin, and basically the way our air brake system is going to work is we're going to have a servo that's connected to a gear, and in that gear is then going to be turning 4 other gears that have fins on them, so that way when the servo turns, all 4 of the fins deploy at the same time. So we don't have any issues with one fin deploying and one not. They all deploy at the same time.
That is our design plan to win the Argonian competition.
Hello, my name is Mason Adolphs. I'm in charge of the 3D modeling and printing for the eBay and the servo motor housing.
Hi, my name is Carson Holmes, and I will be the certified flyer for the Alabama Rocketry team participating in the Argonia Cup. I will also be participating in their team as a mentor, overseeing all of their manufacturing components and making sure that the rocket is sound prior to them actually coming up and flying at the end of this month.
This is our open rocket file. Our rocket coming in at just over 7 feet tall. Our air braking system is stored in the coupler. Directly under it is the eBay, which houses the Arduino, altimeter, and accelerometer, which record our flight data during flight. This is our air brake SolidWorks file. The mechanism utilizes a gear system where a servo motor turns a bronze gear that turns the entire system to open each air brake in unison.